So in this video, we're going to start doing unit conversions. So if I give us something in inches, being able to convert it to centimeters within a system, so grams to kilograms and so on. And then more complicated ones. So if we have something that's miles per hour, be able to convert it to meters per second. And the process that I'm going to use for doing that is dimensional analysis. And this should continue to be reviewed from your chemistry past. I know for sure in 130 they teach dimensional analysis for unit conversions, and in high school I'm sure you did unit conversions also. And I honestly don't really know another way to convert between units other than using dimensional analysis, short of just Googling your answer, which would be cheating. So dimensional analysis is the process that we're going to use. And what it does is it uses conversion factors. And conversion factors are equalities in the form of a fraction. So we're going to use conversion factors. And conversion factors, like I said, are just equalities. So two things that are equal to each other. Right? I know that 7 days are equal to 1 week. So that would be an equality, right? Those two things are equal to each other. So equalities, and then we're going to put it in the form of a fraction. Generally, I'll just give you the equalities, and then when you set up your problem, you'll put them in a fraction. So a fraction just 1 over the other, correct? So if I did 7 days over 1 week, I could also do 1 week over 7 days, right? I'm just taking this equality and I'm making a fraction out of it, one on top of the other. Since they're equal to each other, what are those fractions equal to, right? If I have two things that are equal and I put one on top and one on the bottom, what is that fraction going to be equal to? Yeah, 1, right? Two things that are equal. 6 over 6 is 1. 7 over 7 is 1. 0.1 over 0.1 is 1, right? If you have something that's the same on the top and the bottom, that fraction is always going to be equal to 1. Well, since 7 days is equal to 1 week, right? It's the same as 6 over 6 essentially, then those fractions are also going to be equal to 1. So what we're going to do is we're going to take the number that we're given in our problem, we're going to multiply it by a whole bunch of these conversion factors, basically by 1 multiple times, and then we're going to get our answer. The way that we're going to do that is we're going to make our units cancel. And for that, we just need to remember some algebra, right? If I was to take x, multiply it by y, and divide it by x, because I have x on the top and the bottom, those are going to cancel. And then that answer is just going to be equal to y, right? The same thing, if I have the same unit or variable, whatever it happens to be, on the top and the bottom, they're just going to cancel each other out. So same sort of idea. If I was to take days and multiply it by weeks and then divide it by days, since days is on both top and bottom, it's just going to cancel out. And then my answer is going to be weeks. So same sort of idea. So the version of my conversion factor that I use is going to be dependent on where my units are. Do I need days on top or days on the bottom? And this should make more sense, hopefully, once we go through a problem. And it can be nonsensical, like days, weeks, it doesn't matter. I could do heart. And if I was to multiply a heart by a butterfly, and then I was to divide that by a butterfly, right? Then my butterflies are going to cancel, and I'm going to be left with a heart. So what we're going to do is we're going to take the number that we're given in our problem, we're going to multiply it by some conversion factors. The version of the conversion factor that we're going to use depends on where the units are. Right? If butterfly is on top, if butterfly is on top and I need it to go away, then I need to have butterfly on the bottom. So the easiest way, I think, is to just jump right into a problem. So our first example, we're going to convert 7.42 millimeters to meters. So as far as conversions go, if it's one of the metric system units, prefixes that I asked you to memorize, I'm not going to give that to you on a test or a quiz. So I'm really hoping that you are just going to memorize them and not look them up. We did talk about notes on quizzes, exams. I'm probably going to have you be on Zoom, so I'm probably going to watch, and there's not going to be any notes allowed on exams. So please learn these conversions. So I'm always going to start with what's given in the problem, and that's this number. So that's going to be the first thing I write down once I start doing the math. I do need the conversion factor, however. I do need to know how many millimeters there are in a meter, and that's one of the ones that I said I'm not going to give you, right? It's one of the ones that you need to memorize. So how many, and be careful how I'm saying it, how many millimeters are there in 1 meter? So hopefully you guys are saying 1,000. So 10 to the third millimeters in 1 meter. Now be careful, the way that I said it, right? I wanted the number of millimeters in a meter. If I would have said how many meters in a millimeter, then that's where I would use that negative exponent. Remember we talked in the last video that if we're going to use the conversions right off of that table, right, the negative exponents, and it goes with the base unit. So there's 10 to the negative third meters in 1 millimeter. There's 10 to the positive third millimeters in 1 meter. I like to use the positive exponent version, so this is the one I'm going to use. But if you did the problem with the other one, and we can do it both ways actually, so you can see that I'm telling you the truth, we're going to get the same answer. So I'm going to start with what's given in the problem. That's this. So I'm going to write that down. And then I tend to draw lines. If this is confusing for you, you don't have to do it. What I'm doing is I'm taking 7.42 millimeters and then I'm multiplying, and then I'm going to put my conversion factor here. I just tend to make everything a line. If you don't like that, by all means, you do not have to set it up the way that I do as far as notation goes. So what I'm going to notice is that millimeters are on top, right? Millimeters are on top. I know to make them cancel, they have to go on the bottom, right? If I was to take millimeters and multiply it by millimeters, I get millimeters squared, right? Heart times heart is equal to heart squared. If I want it to go away, it has to be on the bottom, right? We have to divide by it, not multiply. So because millimeters are on the top, I'm going to go and grab this one, and I'm going to put the one that has millimeters on the bottom so that it cancels. So 10 to the third millimeters goes on the bottom, and then 1 meter goes on the top. I'm going to cancel those units. So millimeters are going to cancel with millimeters. I'm going to be left with meters as my unit, which is what we're trying to solve for. So grabbing my calculator, we're going to type that in there. So 7.42 divided by 1,000, or 10 to the third. And we're going to get 0.00742 meters. If you wanted to give it in scientific notation, that's perfectly fine. I would have to the negative third meters. So either one of those is perfectly acceptable for the answer. I did say I would do it both ways, so let's do it one more time using this version. So 7.42 millimeters. Again, we're always going to go back to the original problem. We're going to start with what's given. I have millimeters on the top, so millimeters have to go on the bottom again. This time, and again I'm using this one that's highlighted in orange, 1 goes with the millimeter, and then 10 to the negative third meters go on the top. We cancel those millimeters. We're left with meters as our unit, which is what we're looking for, and I get the same answer, 7.42 times 10 to the negative third. Oop, I forgot to write the negative. Sorry, negative third meters, right? Or 0.00742. If you do need to review scientific notation, please do that. It is something that you should know coming into this class. If you have questions, you can always ask. We should mention significant digits. When converting within a system, of units, the conversion factors are exact. Remember, exact numbers have an infinite number of significant digits. So remember, our rule for multiplication and division is we want our answer to have the fewest, right, the same number of significant digits as our original number with the fewest number of significant digits. So if I go and look, this has 3 Sig Figs. These have infinity because I'm within a unit, right? I'm within a system, sorry. I'm going from the metric system to the metric system, so they're exact. So they're an infinite number. So 3 is smaller than infinity. I want to have 3 in my answer. Remember, those leading zeros don't count, so 0.00742 is only 3 significant digits. So within a system, the conversion factors are exact numbers. So essentially, they're not going to count for significant figures because infinity is always going to be bigger, and we always want the smaller number. And the same thing if you're going between the imperial system to the imperial system, right? So if I'm going from pounds to ounces or, cups to quarts, it's going to be exact numbers. I don't have to really worry about significant figures for those conversion factors. But when we're converting between systems, the conversion factors are measured. They're actually not exact. So within a system versus between a system. So if I'm going between systems, I do need to pay attention to the number of significant digits in the conversion factors. There is one exception to that. Do you guys know the exception? Yeah, the number of inches or centimeters in an inch is exact. So there's 2.54 centimeters in 1 inch. And that is exact. So that's going to be the one exception. So instead of saying 2.54 has 3 significant digits, I would say it has an infinite number of significant digits. But that is our only exception that we're going to see. So let's do another example here. This video is really just going to be a lot of examples. So 6.4 times 10 to the -4th kilograms. And we're going to convert that to milligrams. So I'm within a system, so I can just ignore my conversion factors when I'm figuring out my significant digits, right? It's not that they don't matter, it's just that they're infinite, and I always want the smaller number, and infinity is going to be bigger than anything else I'm going to give you. So at this one, I'm actually going, remember kilo is above our base unit, milli is below our base unit. So I'm crossing that base unit. If you want, you can go direct. You can do this in one step. What I find is that I make less mistakes if I go through the base unit. So I'm actually going to do this in 2 steps. I'm going to go from kilograms to grams and then from grams to milligrams, because then I can just use those conversions that I memorized. If you're going to go from one side of our base unit to the other, then you have to make up your own conversion factor. It's not that you're making it up. You have to figure it out. It's not one that you memorized. You have to combine them in your head. I don't want to combine them in my head. If I do that, I'm likely to goof up. So I'm just going to do the math. So I know, and hopefully you guys are starting to know, that there are 10 to the 3rd grams in 1 kilogram. And then again, I like positive exponents, so I'm going to say there's 10 to the third milligrams in 1 gram. Again, if you prefer, you could say, oops, that's supposed to be a gram. You could say that there's 10 to the negative third grams in 1 milligram if you like it that way better. I do not, so I'm not going to do it that way. So these are the ones that I'm going to use when I do the problem. So just like before, we're going to start with what's given, which is this. So that's the first thing I'm going to write down. If you start with a conversion factor, it's very possible to do the entire thing upside down because you don't know whether 10 to the third grams goes on the top or the bottom until you actually start the problem. If you start with that, your odds, you have like a 50-50 chance of starting it upside down. So don't do that. Always start with what you're converting from, right? What we're given in the problem. So I'm going to take 6.4 times 10 to the negative fourth kilograms. And then because kilograms are on the top, they have to go on the bottom. So I'm going to go up to my conversion factor list here, and I'm going to grab this one because it's the only one of the two that has kilograms in it. And I'm going to put the kilograms on the bottom because they're on the top already. So 1 kilogram goes on the bottom, and then the 10 to the third grams is going to go on the top. And then we can cancel those out. Those go away. We're now left with grams. We don't want grams, right? We want milligrams as our answer. So since grams are on the top, grams go on the bottom. So this one I've already used. So we're now going to use this one. So grams on the top, 1 gram goes on the bottom, and then 10 to the third milligrams goes on the top. I can cancel my units, so grams go away. We're left with milligrams, which is what we're looking for. And then you just need to grab your calculator and type it in. I did these ahead of time, so I'm just going to write down the answer, but it would be really great if you guys would pause the video at this point and actually type it in yourself. A lot of times students will type things into their calculator incorrectly. Like they'll set it up perfectly. They'll get the math, they'll get the chemistry, but then type it into their calculator incorrectly and then get the problem wrong for that reason. So since you're going to have the answer here, this is a really great way to confirm that you're using your calculator correctly. When you're entering something that's in scientific notation into your calculator, please make sure you're using the scientific notation button on your calculator. If you don't, you could get the wrong answer also when typing them in. So just be careful for that. And then if my weird notation is confusing you, what I have, I'll rewrite it the way, I'm not going to do this every time, but just since we're first learning. So what I started with, and then I'm multiplying that by 10 to the third grams over 1 kilogram. And then we're multiplying that by 10 to the third milligrams over 1 gram. So depending on who you've had for an instructor previously, you might have seen it written this way. I just prefer the way that I'm doing it. I learned it that way. I've always done it that way, and it just, I don't know, it makes sense to me. To me, it's easier than multiplication signs and all that stuff. But what I wrote there in the circle is the same thing. And if you want to write it that way, that's perfectly fine. You don't have to write it how I'm writing it. You just need to make sure that you're multiplying and dividing by the correct things. So when you're typing into this calculator, into your calculator, everything on the top gets multiplied and then it gets divided by everything on the bottom. So I would do 6.4 times 10 to the negative fourth using my scientific notation button. And then I would multiply it by 1,000 is probably how I would do it because it's easier than 10 to the third. And then I would multiply it by 1,000 again. And then if there was something on the bottom besides 1, I would divide it by that. Since it's 1, you can just skip that step, right? Anything divided by 1 is itself, so that's just a waste of your time to actually hit the divide button and a 1. So when we do the math, hopefully you guys pause and do it on your own. I get 640 milligrams as my answer. Again, I'm within the metric system, so for significant digits, 6.4 is 2 significant digits, right? In scientific notation, only the coefficient term counts for significant digits, so 6.4 is 2. And then in my answer, remember this trailing 0, there isn't a decimal point, so it doesn't count for significant digits. So 640 is just 2 significant digits. If you wanted to write it in scientific notation, that's fine. You would write it like this. If you write 6.40, now your sig figs are incorrect because of this decimal point that makes this significant. So do be careful. If you're not putting it in scientific notation, the 0 is fine because there's no decimal point. If you're putting it in scientific notation, do not put that 0 there. So another example for us. So this time, we're going to complicate it a little bit, is I'm going to have something that has units on top and bottom, and we're going to convert both. So I have 65 miles per hour, and we're going to convert that to meters per second. So the conversion factors that I'm going to give us, or the equalities that I'm going to give us, I have 1 mile is equal to 1.6093 kilometers. And you don't need to memorize these. The only ones that I ask you to learn are those ones that are within the metric system. So when we're going between systems, I will give these to you. I know that there's 60 seconds in 1 minute. These you probably know, but it's not within the metric system. So if you wanted them, I would provide them. And then 60 minutes in 1 hour. And then we do need to go between meters, right? We're asked to get to meters and we're given kilometers. So that one we do need. However, I would not provide it, right? Because it is one of the metric system units that I said that you needed to know. So if you were given this problem on a test or a quiz or a problem set, what you see right now on the screen is what I would provide. I would not give you the meter to kilometer conversion. However, if I were you, I would write it down so you have everything there ready to go when you start the problem. So we know that there is 10 to the third meters in 1 kilometer. So I got all my conversion factors ready, and then we can just start the problem. So the one of the big mistakes that I see, I'm going to write it incorrectly. Well, let's write it correctly first. Is just starting it. I have 65.0 miles per hour. So when I do these lines, miles go on top and hours go on the bottom. Biggest mistake I see is folks will do this, 65.0 miles per hour, and they'll put them both on top. The problem with that is, and we can just do it right now, to get rid of hours, because hours are on the bottom, I have to put hours on the top. So I'm going to go up to my list of equalities. I'm going to find the one that has hours in it, which is this one, and I'm going to put 1 hour on the top. And then 60 minutes is going to go on the bottom, and then those are going to cancel. Remember, they have to be opposite to each other to cancel. If I would have done it incorrectly, then I have hours on the top, so I would put 1 hour on the bottom, and I would put 60 minutes on the top, and I'm already wrong, right? To do it correctly, I need to divide by 60. In my incorrect way, I'm actually going to multiply by 60. So be really careful. If it's miles per hour, it's miles over hours. Miles on top, hours on the bottom, not both on top. So this, do not do. Don't do. So back to the correct way. We left off with minutes. Minutes are on the bottom, so minutes go on top. So I'm going to go up to my list. I'm going to find the one that has minutes in it. Since minutes are on the bottom, the 1 minute goes on top, and the 60 seconds goes on the bottom. And then I can cancel. I would highly recommend physically canceling like I am, how I'm taking the red and I'm actually drawing lines through it. It's really easy to set it up correctly, incorrectly, accidentally, and then you'll catch those mistakes when you go to cross them out, right? If you have them both on the top and you go to cancel it, you'll catch yourself. I've done that in class before. Like when I get tired, I'll start doing it wrong, and usually like I'm hopefully covering it and you guys don't notice, and I fix it real quick. But I catch it every time because even though I've been doing this for a really long time, I still draw those lines through it. It's the best way to catch your mistakes. So even though it's a little extra like pencil work, I would still always recommend doing that. So we're trying to get seconds on the bottom, right? That's what we're looking for, and we have that right now. So we're done with that part. We still have to convert miles to meters. Miles are on the top, so miles have to go on the bottom. So I'm gonna grab the conversion that has miles in it. And like we just said, the 1 mile is gonna go on the bottom. And then 1.6093 kilometers goes on top. I'm gonna cancel it. And then we're almost done, right? If we were to stop right now, my units would be, my units would be kilometers per second. That's not what I want. I want meters per second, so we're not done yet. Kilometers is on top. It needs to go on the bottom. Grab that conversion factor. And then we can cancel our last one. And if we look to see what's left, I have meters on the top, seconds on the bottom. So meters per second, which is what we're trying to solve for. So now we just need to grab our calculator. And again, I have the answer, so I'm just gonna write it down. But I would really highly recommend that you guys get your calculators out if they're not already and actually type this in to make sure you're doing it correct. Right? Just because you can set it up correct doesn't mean you're going to get the correct answer. So please practice it. So what I would type in, you can do this in any order of operations with multiplication and division. This isn't going to matter. So I tend to do all the stuff on top first and then the stuff on the bottom, but you can just kind of go in order if you want. So I'm going to take the 65. I'm going to multiply it by 1.6093, right? The ones don't matter because it's not going to change your answer at all. And then I'm going to multiply that by 1,000. And then I'm going to divide it by 60. I'm going to divide it again by 60. And then I'm going to get my answer. Again, the ones don't matter because you're going to get the same answer. So don't waste your time typing those in. The other way is to just go in order. So 65.0 divided by 60 multiplied by 1.6093 multiplied by 1,000. You'll get the same answer, whatever order you do it in. So whatever's easier for you. If it's easier to just go left to right, and if it's on the bottom, divide. If it's on the top, multiply. By all means, go for it. So, oops, sorry about that. I'm still learning my iPad here. So give it a pause, give it a shot, and then come back. So hopefully you guys did that. And I got 29.1 meters per second as my answer. Significant digits, let's go through here. Let me grab a different color. So 65.0 is 3 significant digits. 60 minutes to 1 hour is an infinite number, so infinity. 60 seconds in 1 minute, infinite. So this one is between systems, so 1.6093 is actually 5 significant digits. And then the last one is within a system, so infinity. It's a horrible infinity sign. So of the green numbers I wrote down, 3 is the smallest, so I want 3 in my answer. I have one more example for us. This one's going to be kind of long, and then I will turn you loose to do this on your own. So this one, we're going to convert 2.70 grams per milliliter. And I'm going to convert this to pounds per foot cubed. So again, we're doing the top and the bottom, but there's something particularly tricky about this one. So conversions that we're going to be given, I have that 1 kilogram is equal to 2.20, the decimal point there, 46 pounds. I have that 1 inch is equal to 2.54 centimeters. Remember, this was our exact exception to between systems of units. And I know that there's 12 inches in 1 foot. The other piece of information that you're missing is you do need to convert away from that milliliters. So we do need to go from milliliters to centimeters cubed. And that is one conversion that I had asked that you know. So 1 cc, 1 cubic centimeter, is the same as a milliliter. So I do want you to know that one. So this is what we're going to use to do the problem. And again, on that list, the only one that you would need is the milliliters to centimeters cubed. I would provide the other conversions as part of the problem. So we need to start this one kind of small. I'm going to start far over and I'm going to write pretty little because this one's going to get long. So I'm going to start with 2.70 grams. And then remember, grams are on top, milliliters are on the bottom, right? Don't put them both on top. There's a decimal point there. So I'm going to do the gram conversion first. You could do the milliliter conversion first. It doesn't matter. I just know that the gram one is a little bit easier. Oh, we are missing one conversion. Do you guys notice? I have kilograms to pounds, but we actually need grams to kilograms also. I would not provide that one either. So we know that there are 10 to the third grams in 1 kilogram. We're missing our very first one. So that's the one we're going to use first. I have grams on top, so 10 to the third grams are going to go on the bottom. And 1 kilogram is going to go on the top. I'm going to come back and convert those in a second, or cross them out. I have kilograms on top, so kilograms go on the bottom. So we're going to use this one. So 2.2046 pounds. And then let's cross those out. So these grams canceled, these kilograms canceled, and then left with pounds on top, which is what we're looking for. So that part's done. We still have to type it into the calculator, but we're done setting up the problem. So I have milliliters on the bottom. If I go back over to my conversion factor list, this is the one that has milliliters in it. So the 1 milliliter is going to go on the top. And then 1 centimeter cubed would go on the bottom. What we need to remember is that a centimeter cubed is literally a centimeter cubed, right? It's centimeters times centimeters times centimeters. And I'm actually going to write it out so I can make my point. If you want to leave it as centimeters cubed, you can, but just be really careful. I'm going to cancel those guys. So I now have centimeters on the bottom. I'm going to go back to my list. I'm going to grab the one that has centimeters in, which is this one, because centimeters on the bottom, it goes on the top. So 2.54 centimeters, and then 1 inch goes on the bottom. So this is where you have to be careful. This centimeters only cancels one of those centimeters, right? Centimeters does not cancel centimeters cubed. Centimeters cancels centimeters. So what I have to do is I have to put that in 2 more times, 3 times total. 2.54 centimeters, 1 inch, 2.54 centimeters. We're going to run out of room, 1 inch. Now I can cancel all of them. So this centimeters with this centimeters, this centimeters with this centimeters. I now have inches cubed on the bottom. So when I go, we're going to have to continue it down here. When I go to finish the problem, I'm going to have to do the next one 3 times. So inches are on the bottom, inches are going to go on the top. I know that there's 12 inches in 1 foot, and that inch, sorry if this is confusing by having to put it on a different line, is going to cancel with that one. 12 inches in 1 foot, that'll cancel another one, and then one more, 12 inches in 1 foot. Now I can finally get my answer, right? Those inches canceled, and then those inches canceled. I'm left with feet cubed on the bottom, right? Feet, or foot cubed, feet cubed. Foot times foot times foot is feet cubed. So just be careful. If you didn't want to write it out 3 times, you do not have to. You just need to make sure that you're cubing the number as well as the unit, right? So I'm just kind of leaving off. I'm just going to rewrite part of it where I had the 1 milliliter, right? The rest of it is still here. We're just skipping that part. Over 1 centimeter cubed, right? I said you could leave it that way. Then what I need to do is I need to do 2.54 centimeters cubed. Oops, sorry. I'm starting to get tired. It's been a busy day. 2.54 centimeters cubed, right? We need to cube the number and not just the unit. So when you type it into your calculator, you need to remember to cube the 2.54, not just the centimeters. And then I have 1 inch the whole thing being cubed. And then 12 inches, again, the whole entire thing being cubed, the 12, not just the inches, otherwise you're gonna get the wrong number. And then 1 foot cubed. So if you don't want to write it out 3 times, you don't have to. Just be really careful when you're typing it in that you're going to multiply it by 2.54 times 2.54 times 2.54, right? Not just 2.54 once. You can't just cube the unit. You have to cube the number also. So same deal. Please pause the video, type this into your calculator yourself, and see if you get the same answer as me. So I got 169 pounds per feet cubed when I rounded to the correct number of significant digits. It was like 168.55, but that 5 is going to round the 8 up to a 9, so 169 pounds per feet cube. Let's go through Sig Figs real quick. So this is 3 significant digits, infinity. This one, 1, 2, 3, 4, 5. Infinity. These guys were exact. So infinities starting to look like 8s. Infinity, right? These are within the same system, infinity and infinity. So 3 is my smallest number. I want 3 significant digits in my final answer. So please do some practice problems. I do have some posted for you with unit conversions.